Thanks, Ali. Hi, everybody. Welcome back. Welcome to the Decarbonization Session. This is a highly anticipated one. We've got three excellent speakers lined up. We're going to be covering both electrification and energy efficiency on this panel. First, we've got Scott Blunk. Scott is the strategic business planner for electrification, energy efficiency, and distributed energy at the Sacramento Municipal Utility District. Then we've got Delia Gutiérrez. Delia is professor of climate change and energy use at Tecnológico de Monterrey in Monterrey, Mexico. And finally, Angela Mu. Angela is the energy manager at Weill Cornell, the medical campus. So first, we've got Scott. We're going to be going in this order. So we'll turn it over to him first. We're going to be running logistics the same way we did the previous panel. We'll have our three presentations and then 20 minutes for Q&A. So please do continue to make use of that Q&A panel, and we'll get to as many of the questions as we can once our third speaker wraps up. So with that, Scott, I will turn it over to you to share your screen.
Okay, I'm gonna keep it in this mode because I know the struggle. Okay, all right. Thanks for inviting me to attend and present. I'll go over Smud's building electrification strategy. I lead our corporate strategy on buildings. And I'll dive in, and I'm going to, some of this is going to be controversial just because that's kind of the way I roll. I think I just want to be real about this stuff. You know, really the first step in what we did at Smud is, or one of the many steps, I suppose, maybe not the first, but an early one that's important to realize is that electrification is energy efficiency, and efficiency can be talked about in many different ways. But what I realized at Smud is we were doing energy efficiency and we'd been doing it for decades. But really, we'd not been doing energy efficiency. We'd been doing electrical efficiency. So pulling these apart was kind of important, and important to Smud to realize, A, that we'd been doing electrical efficiency. We are an electric-only utility. And for that reason, we've been doing, our EE had been focused on electrical efficiency. But there's the other side of this, the natural gas efficiency. And really, electrification efficiency is just getting, you know, some people call it beneficial electrification, but there's definitions for that. It's really just about displacing natural gas use or any other type of fossil fuel use in buildings. And that is also a term of efficiency. And why this is important is because we had, you know, 50 people or something inside Smud working on quote unquote energy efficiency. And their whole goal for 20 plus years has been to reduce electrical energy consumption. And now we're asking them to increase electrical energy consumption. And so kind of changing this paradigm in their head around now their goal is not just to reduce consumption, but actually increase consumption, and why was really important. And it's a battle that still is going on today. They're wanting to run electrification programs like efficiency programs, and they're very similar, but there's differences. And really, the initial pushback was really strong because I think they saw it as an existential threat. You know, they've been reducing demand. Now you're asking to increase demand, but bringing these people, these energy efficiency people along was super important because they're the ones with the expertise on how to run programs, how to talk to building operators, how to talk to building owners. And so once they saw this, the need for them in this new paradigm, but also the fact that their budgets are going to go up 200% or more, pretty dramatically, also it gave them a lot more comfort as well. So this was really important, and I don't want to under stress the value of, there is a difference between EE programs and electrification programs, but there's also more similarities. Anyway, I'll move on. SMUD's electrification goals. So SMUD serves Sacramento County, not just the city. We are quasi-governmental, so we're not under a governmental organization. We're a nonprofit that serves our community, and the community is 7 different local jurisdictions. So our goals kind of go across many jurisdictions, and we work with each one of them along the way. But in the early days, I started in 2018, and we stood up programs pretty quickly, and just, I'm not going to read all this, but our starting point was about 18% of the buildings were all electric as our starting point. And we now have programs in electrification programs in every building sector. And then by 2030, we hope to hit 35% all electric buildings. So that's a combination of residential, commercial, industrial, all of those, but 35% of the buildings to be all electric by 2030. And then by 2040, the goal is to have 100% of low income electrified. And I'll emphasize that point later on. And by 2045, to have 100% of all buildings electrified. Some people balk at the 100% number, like, because it's too scary, and 100% is really challenging. But when I was in school taking a test, I didn't try to get 90% or 95%. I answered every question to try to get 100%, and knowing that I might not get there, but 100% was always the good goal to shoot after. So we're approaching it in that direction, knowing that we may not get there, but it's the right goal to have, I believe. And just a little bit about carbon emissions and where they're coming from. This is a single family home, but I think, we all live in single family homes, or maybe multifamily, but also it kind of applies broadly across the sectors, and just where the emissions are coming from. And so today, the natural gas contributes 2.5-3 tons of carbon over an all electric building per year. That's the carbon equivalent of something like planting 40 trees a year, 40 trees per year for every single year that you continue to operate your building with a mixed fuel building. And this is a single family home. It's also the equivalent of 1 vehicle per year. So it's not an insignificant piece to the climate puzzle. And, in future years, our grid's getting cleaner. This was created before SMUD had the goal of being 100% carbon free in our electric supply. That's not a net, it's an absolute goal by 2030. So if we can stay on that trajectory, the carbon from operating a building, an all electric building, will be 0, except for the refrigerants. And of course, we're working on the refrigerant piece of that as well. Bill impacts, residential bill impacts. Again, we all live in homes, but this is kind of more broadly. SMUD has some of the best electric rates, the lowest electric rates in the country. This chart represents SoCal, Edison, PG&E, and SMUD. But SMUD is certainly higher on the savings per home, and that's just based on our rates. Our rates are lower. So not only can we get carbon savings, but we can get lower operating costs for our customers. This is, again, single family. It doesn't always apply as well to commercial buildings because there's the demand charge as well in there. And it's just something that we're working on. The early push in our programs has been residential, largely because there's so many of them. Also, the buildings are pretty homogeneous. I would say 80% of the buildings have a 40-gallon gas water heater. and probably half of those is in the garage. So it's fairly well-known building stock that's easy to transform. Where you get into commercial and industrial institutions, every building can have a different type of water heater, a different location, a different size. So it's more challenging, but we've got programs there, and we're learning every day. And why are we doing this? Buildings are almost as significant as light duty vehicles in the pollution it releases for NOx, which is ozone and PM 2.5, which causes respiratory issues. Power plants are really a small piece of that. They get a lot of attention. And maybe that's just because there's so fewer of them than the buildings, but they're really not the problem today. Buildings and transportation are for sure. And then premature deaths as well. Buildings, the last couple of surveys have kind of led on what's causing premature deaths related to outdoor pollution. So it's certainly a serious issue. And bringing it home, I think this is kind of the most impactful. Everybody wants to cook on gas, they think, at least until they've tried induction. It's a wonderful alternative. But gas cooking in the home raises the risk of asthma 42% for episodal asthma and 24% lifetime. So it's a big deal for people with children. And also induction is just safer for the elderly. It's safer for everyone. I've walked into my house with the kids, had the gas on, but not lit. Not anymore. I do have induction now. And this is, it's a big one to change, but it's also really pretty simple too, because you can go straight into an induction, kind of a portable induction unit, which will serve most of your cooking needs. At least for this household, it will. And I know there's also, speaking to the universities and such, there's there's a lot of induction equipment out there for benchtop units. We've done webinars on the electrification of commercial and lab settings. And so it's all feasible out there. And really the other kind of big reason why we want to do this. So the graph on the left was produced by E3 in one of their studies about where we're going to go if we electrify, kind of the high electrification scenario, where gas prices are going to go. And it's pretty dramatic. I took that on the right and kind of applied it a little bit differently to show some of the results. But for an annual gas bill of $540, today's about $1.50 a therm in our territory. If you just electrify 10% of the buildings, so you're getting rid of 10% of the gas demand, you have to redistribute all of that infrastructure cost to the 90% that are still on the grid. And the majority of the cost of natural gas is in the infrastructure, the pipes, the safety requirements. And that's going to cause a 66% increase in gas bills with just the first 10%. And it goes up very dramatically after that. And I'm hoping before we get to the 50 and 75% level that we'll have policies in place that can address this, because gas prices going this high are going to be untenable for most of society, but especially our most vulnerable populations, low income, disadvantaged people. So this is kind of where we're headed, and trying to stave that off. And that's why our low income goal is 5 years ahead of the general population. There's one of the big barriers is the infrastructure, and not necessarily the infrastructure on the grid side. The Smud's electrical infrastructure is ready for building electrification. The larger challenge is going to be on the building side. we are estimating about 25% of the panel will need to be upgraded. But I think that doesn't emphasize the fact that 100% of the buildings that have gas today will need, at the very minimum, circuits and wires. And getting the buildings prepped for that is very important, because for people who don't do the planned replacement, when a piece of gas equipment goes down, the speed at which you can get something going again is really important. And once you install that new gas water heater because you didn't plan for it, or gas whatever, nobody likes to throw away equipment that's still working and has a lot of life on it. So really, that new gas appliance is going to be stuck in that building for probably 20 years. And we've missed an opportunity. So getting buildings ready to be decarbonized is critical to really moving this forward. Because it's all about time to replace, and getting the building operating again as quickly as possible. And this, probably on the quick side would take weeks to get a building ready once something has gone down, but it could easily take months, and and multiple months, especially if transformers are involved. So getting the building level infrastructure ready is probably a bigger deal than getting the utility side ready, because buildings really don't add, the load that they add is, for our territory at least, the load that they add is off peak. Our peak is summertime, high heat periods, and we're already built out for that. Few electrification loads are going to be adding to that peak, but what we've found is when you electrify space heating, you're often getting a new, more efficient air conditioner at the same time, so you're actually lowering our peak. So electrification is good in our territory. Where electrification doesn't is on the vehicle side, right? Vehicles are going to be a whole nother strategy in the large load that they bring, but the grid is certainly ready for the buildings themselves. And some of our programs offer some of the highest incentives, I think, in the world. And I'm not going to go through this in detail because I don't think it's all that pertinent, but if you've got a gas appliance that I want it replaced, we will find you an incentive or create one for you to get it done. Because the organization is very well aware that if you install a new piece of equipment, it's going to be stuck there for a long time. And, like 2040 is only 19 years away. So anything that's being installed today is probably still going to be there. And in a few years from now, we've kind of missed our date to electrify everything, at least at natural replacement. And my last slide, maybe to sober us all up a little bit, but in general, electrification is pushing that rock up the hill. Customers don't want it, and contractors don't want to do the work. And I am a general contractor. I had companies before this, and I get it from their standpoint. It's riskier to them. It's new, and so anytime they have to price in the risk. So we need our contractors to make more money doing this. That's the only way. We can't be pinching pennies here, because once they see that they can make more money doing this, they will align around it. And the customers don't want it. I mean, the average customer out there doesn't know this is a problem. After all, they're using natural gas. It might as well be called organic gas, right? Like, it sounds good for you. And it's clean. We've been telling them that natural gas is clean for generations at this point. So we have to really get people to understand that their home is a very big part of this problem. And it's one, you don't have to go buy an $80,000 new Tesla to do it. With incentives, the incremental cost can be a savings to the customer. and their bill savings will be there as well. It's more about the time to get it done when they're in that emergency. And I will hand it over there. Thanks.
Thanks, Scott. That was great. Definitely a sobering last slide there, and I can't wait to unpack that some more in our Q&A. But now let's turn it over to Delia Gutiérrez from Tech Day Monterrey, and I trust you will correct my pronunciation there, Delia. Please feel free to share your screen.
Thank you. Thank you very much for having me. Okay. Hi, everyone. I'm Delia Gutiérrez from Mexico. Thank you so much for having me. I'm going to talk about Tec de Monterrey Sustainability and Climate Change Plan 2025 and Action to Decarbonize 26 campuses. I'm from Mexico, and my university is it's located around the country. So I'm going to let you a little bit about the Tec de Monterrey University. Tec de Monterrey was founded in 1943, and it's a private nonprofit and independent institution with no political and religious affiliations. And it's committed in high quality education, and the board members get together every year to define different goals in order to reach sustainability and development in many communities around our nation. These are some numbers about our university. We have 26 campuses for grad students, and we have 18 offices around the world. Currently we have 92,000 students, more than 92,000 students. 58,000 students are undergrad, 27 are studying high school, and 6,011 are studying a postgrad. So 4 entities are part of Tec de Monterrey group, and one of them is Tecnológico de Monterrey, the university that I already mentioned. The other one is Tec Salud. Salud in Spanish means, in English it means health, and that is our health department. The Tec Salud is made up of the School of Medicines, the Health Sciences department. We have 2 big hospitals. The picture on the left is San Brano Leon Hospital here in Monterrey, and some specialty institute and associate institutes. We already have 100% COVID hospital named San Jose. And we have another university, it's named Universidad Tec Milenio. That university is composed by 32 campuses and over 60,000 students. And we also have a raffle organized by the institution named Sorteos Tech, and that investment goes to scholarships, programs, and infrastructure for the university. So recently in this year, in April of this year, we launched the 2025 Sustainability and Climate Change Plan, where in this plan, we try to be a sustainable institution. We are adopting a proactive culture in the face of the climate change emergency we are facing now. And this plan is reflecting different action that we are trying to make in all of our campuses. The 6-axis plan involves every area in the university. Those areas are culture, mitigation, adaptation, education, research, and bonding. I'm going to focus on mitigation and adaptation that are the main actions from the facilities area. So regarding the mitigation axis, we are trying to reduce our footprint or carbon footprint, and we try to promote water management and integral waste management system and reduce our energy use. In 2019, we consumed over 100 millions of kilowatt hours. So we have a big challenge because we are consuming a lot of energy. So our goals are set to reduce 20% of the current consumption based on 2019 consumption. And we are trying and we are achieving to get 80% of our energy coming from renewable energies sources, such as contracts, or it can be also self-generation in our campuses. And we are reducing our 50% greenhouse gases. In 2019, I'm telling you the 2019 data because that was our last year of full operation because of the pandemic. So in 2019, we had 56,000 tons of CO2. That is our number of emission we try to reduce by 50% in 2025, and we are gonna try to be, we have the commitment to be a carbon neutral carbon by 2039. In terms of water, we set 20% of savings in water consumption, and 80% of our facilities of all of our campuses are going to have water treatment plants or some kind of reused water. And we consume over 4 million cubic meters in 2019. And in terms of waste, we are adopting a new strategy to manage all the waste we produced. For example, in 2019, we produced over 10,000 tons of waste. So what is the institution doing or to avoid or to reduce the energy, the water, and the waste we are producing? So we have different actions, such as reducing our consumption by the replacement of equipment or utilities by new technology. In water, we are established a central management area, which I lead. In waste, we are implementing a national new model, and we have guidelines and new standards, so we can run our processes in a different way. So I'm going to show you 3 examples of the action we are making in our campus. And the first one is called Green Ship. It's a district cooling and heating. We are very excited to have this new district. And the Green Ship project will enable the necessary infrastructure and existing and future for the existing and future buildings that are going to be built in Tecnológico de Monterrey. This is on the right. You can see our Monterrey campuses. I forgot to tell you that we name the campuses after the city they are located in. For example, Campus Monterrey is located in Monterrey City. Campus Ciudad de Mexico is located in Mexico City, and more or less. This new district is going to provide for the new buildings, the pink one, are new buildings to be built. And it's going to provide HVAC, hot water, firefighting system, drinking water, and every electrical connection that we need to create or to install for giving a new facilities for all the students. For example, in this project, we need to provide almost 15,000 cooling tons and 119 millions of British thermal units to provide of heating. So it's a very, very huge project that we are running right now. And we have provided HVAC, hot and cold water, and HVAC for the polygon and academic mixed uses. What is the challenge of this project? We ran different business cases, so we could make the decision of how we're going to build this district. We analyzed having standalone systems in every building versus having a new district, and we decided to have a new district because the cost of maintenance and energy costs are going to be lower by the passing of time. This is another project. It's called E2. It's a parking building. It's a net zero building, and we are trying to reach the zero energy building certification. Some numbers of this project, we need water to provide. We need water to provide toilets, sinks, green areas irrigation, and we need to power for 6 elevators, air conditioning, electrical, water pumping, and monitoring systems. So we need to be, we made this building net zero consumption. So what are the technologies we are including in this building? We are including PV cells, rainwater harvesting systems, wastewater treatment plants, water condensation from atmospheric humidity, and BMS control. What are the benefits of having this net zero building? In terms of energy, we are about to produce 500 megawatt hours per year. And we are going to consume energy from renewable, reducing 300 tons of CO2. In terms of water, we are facing a drought periods, or we are facing a drought crisis here in Mexico and around the world, of course. And in terms of water, this project is going to help to recharge the water wells we have in our campuses. And it's going to avoid over 500 cubic meters of water every year. And the monitoring system is going to help us to have a new culture where we take care of our consumers. We are going to take care of every energy, water, and we are going to monitor it for different uses such as education. And also we are running energy audits. And energy audits is analysis of energy flows to energy conservation in buildings. So, and these are 3 different cases. We run different energy audits around, I forgot to mention that we have over 900 buildings. So we need to review every building and try to make it more efficient. So in the first one, in the left is the School of Medicine. They had a problem because they had high temperatures, and we need to decrease the temperature and also keep our equipment running because they have very specialized equipments that need to be run efficiently. So what we do, we ran a 3D model, and we decided to separate the space of equipment and move everything else far away from the equipment. So we installed some barriers to keep the heat inside the building, and also inside the building with the equipment, not with the people. And also we installed millimeters film on glasses, so we could decrease the temperature over 3 centigrades. The other one below is our governance building. We had another problem there. We have some areas with very heat. We kept the heat in those areas. So what did we do? We replaced the lighting, and we also mitigate internal cooling losses with several divisory doors. And that saved 46% energy consumption after the lighting replacement and over 20% in cooling consumption. And the one on the right is Zambrano Leon Hospital. That's the picture I already showed you. And this was a different case. We didn't have thermal comfort in the hospital. So during winter seasons, we had a problem with all the patients and people that were gathering there, because in the lobby area, we had an increasing of temperature due to air inlets from the from a revolving door that we had in the entrance. So we couldn't remove the revolving door. So what we did was to install some locks, an air curtain, and also try to double the height of the curtains to retain the air inlets from the outside. And that helped us to move our set point in our HVAC system to increase it one centigrade. And that helped us to give more people a comfortable sensation where you go to the hospital facilities. And this is the last one, axis adaptation. What we are doing in our university is trying to adapt to climate change. And we need to prepare all the buildings, not only to be efficient, but to be resilient. Because in Mexico we have floods, we have drought periods, we have like a short periods of raining, and then we have droughts. So we need to prepare the buildings to be more resilient, and we are adopting different technologies so we can restore our facilities, we can replace some of our technologies, and we are trying to make a resilient campus. We have 39 campuses for Tec de Monterrey and over 28 campuses for Tec Milenio to big hospital. So we have a lot of work to make our campuses resilient, and we are strengthening and implement different standards in order to get it. And thank you so much for the opportunity to be here. If you want, I'm leaving the link if you want to know or learn a little bit more about our sustainability and climate change plan. Thank you so much.
Thank you so much, Delia. Ali, maybe you can put this link in the chat so folks can save that.
Of course.
Moving on to our next speaker, Angela Mu from Cornell Medical. Angela, go ahead and share your screen when you are ready.
Does this look okay?
Great.
All right, great. Good morning, everyone. My name is Angela Mu, and I'm the Energy Manager at Weill Cornell Medicine, the Medical College for Cornell University. I'll be talking about how at our main campus, Weill Cornell is taking action to reduce carbon through improved training of our operations and maintenance staff. In 2018 to 2019, Weill Cornell created a structured training framework for the engineering and maintenance department. And we did this with the help of a nonprofit coaching partner and an energy efficiency grant. We started this because we saw an extremely competitive hiring environment in New York City, and we weren't finding job applicants with the desired skill sets. So we decided to use this grant opportunity to formalize a way to upskill our new and existing hires. And I'll say, although this training program is a few years old by now, I think the general theme of having to work around a shortage of skilled labor is even more relevant today in 2021 than it was back then. And I think that this is something that all of us going forward in order to meet our sustainability goals is going to have to do, to train towards the labor force that we need rather than the labor force that exists. So first, a bit of background. We are the medical college for Cornell. We were founded in 1898 in New York City. While Cornell has affiliations with a number of hospitals, most notably our teaching hospital, New York Presbyterian. While Cornell has a three-part mission of medical education, patient care, and research. The college footprint has grown significantly over the years. From our first main campus location, we now own or lease space in 39 different locations in New York, totaling about 2.8 million square feet. Our main campus has more than doubled its square footage over the past 15 years. So finding enough skilled technicians, especially with controls knowledge to manage these spaces, is a constant challenge. So back in 2018, we were seeing and still are seeing a very limited applicant pool. Few people applying had relevant experience working in medical spaces or research spaces, and most resumes that came in had zero reference to building management system exposure. And we did look into temp agencies in the past, but we found that they weren't much help either. This led to taking a long time to fill positions, which put extra stress on the teams and increased repair time. We also started to notice that within our mechanical and electrical shops, we were seeing broad skills gaps, and that led to a tendency within teams of relying heavily on a few rock stars and stretching them too thin. So what we needed was a system that would continue raising the bar and eventually close these skills gaps within our shops. And our thinking was, if we could find a way to build these skills internally, it would really open up the job applicant pool. And this was all in the midst of increasingly ambitious regulatory goals in New York City. So starting a few years ago in New York City passed a series of laws which will start assigning financial penalties for excessive building carbon emissions starting in 2025. Before 2018, we did have existing training within the department. We had mandatory HR and environmental health and safety trainings. And then also new employees would get some sort of basic building management system training from their supervisor. They'd also get some on-the-job technical training, mostly through shadowing experienced technicians and rotations. And then there were occasional capital project turnover trainings and walkthroughs from vendors and contractors as well. Beyond the mandatory trainings, there was an organization-wide tuition reimbursement program, but it was pursued by only a small number of staff. Classes had to be on your own time, and staff had to have the funds to pay for these trainings or classes up front and then get reimbursed later. We did make BMS vendor trainings available at our vendors' local branch offices. These were paid for up front by the department, but they typically only happened when employees were proactive about approaching their supervisors about these opportunities. So we started to revamp our training approach because of a workforce development grant by NYSERDA, which is the New York State Energy Research and Development Authority. The point of the grant was to help building owners reduce energy usage by training their workforces better. And the great thing about the grant was that it was very flexible. We partnered with the nonprofit Urban Green Council on our proposal, where they would act as coaches and advise our management team on how to develop a training program. Our proposal was awarded funding in August of 2018, and our goals going in were: 1, to build the framework for a structured training program, 2, do a lot of technical training, and 3, build a strong energy culture in our department. And we hoped that by doing these 3 things, we would improve the way we operate and maintain our buildings, and also achieve energy savings. So after we won the grant, the first thing we did was we had to evaluate where our team stood, and Urban Green helped us develop a set of surveys for the team. There was an anonymous culture survey that helped us get a sense of how people felt about training and their preferred learning style. We learned that most people preferred hands-on training and that 85% of the staff felt that training was very important the way they did their jobs. However, we also learned that less than 60% of staff had ever requested any training. And also 20% of respondents said that they didn't know who to go to with their energy savings ideas, which was a shock for me because I was the one delivering the surveys. So that kind of told me that I'd been working closely with the supervisors for a couple of years on energy efficiency, but it hadn't penetrated down to the staff level. The other survey we did was a skills survey. That one had name attributions because we asked folks what trainings they wanted to be signed up for. And we also interviewed the shop supervisors to get their feedback on their team's training needs. So Urban Green helped us compile the survey results into a large multi-tab spreadsheet. This is a little clip of it. The number one type of training requested by everyone was controls training, building management systems trainings or lighting controls trainings. After that, the next most popular type of training that was requested was an assortment of individual equipment trainings, HVAC system trainings, and troubleshooting trainings. This pie chart shows the split of the trainings that we ended up sending people to. So our grant reimbursed $106,000 for out-of-pocket expenses. We spent about half to build a training center, and then the other half was spent mostly on controls training as people had requested. So it's BMS training and lighting controls training. And then the rest of the reimbursed trainings were an assortment of HVAC and electrical trainings. We also had a cohort attend an Urban Green G-Pro or Green Professionals class. That was to teach green building fundamentals. In addition, experienced team members developed a set of in-house trainings, which now live in an online library that we created. When we added up all of the trainings and the best practices sharing, we found that the department spent over 800 hours just attending trainings. This is over about 50 people, not including the time to manage the training program, travel, or develop in-house trainings. So it was a big effort. Next, I'm hoping I can just walk you through the training lab that we built. Okay, meet our training lab. We built this training center for a couple of reasons. The first is we didn't have a dedicated space for trainings before. We used to just kind of crowd into small conference rooms. The second was for onboarding new staff. So new staff before had to learn on the job while they were completing work orders in kind of dusty, cramped environments with occupants only a few feet away. So in contrast, this is a much less pressured, calm, well-lit space. And it's meant to hold a lot of representative equipment on campus so that staff can come to learn and experiment and really take their time. And if they break something in this room, it's 100% okay. That's what it's here for. So this room was built to simulate a wet laboratory. It's one of the more complex environments on our campus. Wet labs are almost always negative pressure, and that's a concept that's new to most onboarding staff. So to simulate it, we have a line of supply and exhaust ductwork, each with 2 sets of controllers, one for each BMS vendor that we have on campus. And these are real controllers with functioning dampers and actuator components, and they're connected to BMS panels in the room. Here are the BMS panels. And then we have a ladder so that you can get to everything easily. In addition, we have a fume hood. This is a real fume hood that was getting decommissioned, and we salvaged it for the room. It's connected to a functioning fume hood controller and an exhaust fan on the other side of the wall that can turn on and simulate fume hood exhaust flow. We also did lighting. So the most complicated lighting system on our campus is a Lutron quantum system. So that's what we installed here. We have 2 rows of lights, one linear and one 2x2. One set is on a simple relay and the other is dimming capable. There's also an occupancy sensor connected to the lights, and everything connects to the Lutron panels over here and can be fully programmed. We've got some bulbs and porcelain holders that simulate daylight for this daylight sensor. And in the corner, we have an operable window shade. So we pretty much have one of everything. And this is how we can do trainings on programming schedules, how daylighting works, how to create zones, program window shades, occupancy sensor functionality, and demand response. And then all the systems, the BMS and the lighting controls are available from these 3 workstations. And we've got a large TV screen for group presentations. So we've used this room a lot already. We used it for onboarding, wet vac training, plumbing clog training. We've had engineering consultants present on energy efficiency projects in this room. We did have to pause the use of this room during COVID because we're trying to spread shops out, and this ended up being an office for 2 people, but we're hoping to restart the use of this room later this year in the winter. So let me go back to the presentation. Okay, so at the end of the grant, we had to create, a training framework. We formalized a few things going forward. We made 2 types of training standard for new employees. One was a green buildings training. We found that these were really helpful in bridging the gap between people's day-to-day work and understanding the bigger picture of energy efficiency and sustainability. The next were vendor BMS trainings. Instead of kind of the light level overview that supervisors used to live, now we send people off-site to vendor branch offices for training. Just because controls knowledge is so critical for high performance buildings, they really need kind of a thorough introduction. Next, we created a set of formal training requirements for each specialist level. And this helped us be consistent with what we expect, for example, a mechanic helper to know versus a senior mechanic specialist. So the picture on the right is part of one such training requirements document, and we created a version for each technician level. And lastly, we required a training goal as part of the annual performance appraisal process. And that was a way that we could emphasize continuous learning even after the grant. When we applied to the grant with NYSERDA, we aimed for a 3% reduction of energy usage on campus due to training. Between our baseline and final year, we achieved a 4% reduction in electricity, a 1% increase in district steam, 25% reduction in chilled water, and 15% reduction in natural gas. So we didn't meet the target for district steam, but we did in the other categories. And I will add that we had a bit of fuel switching between purchased chilled water and self-generated chilled water from district steam. And that accounted to some of the large drop in the chilled water numbers. The last thing is the last 6 months of the final year of reporting fell into COVID. And I tried to account for that, but it was pretty tough because the campus was changing pretty rapidly. So there were a lot of things I couldn't account for in the end. Okay, finally, so the third goal we had for this training program was to build a stronger energy culture. I think a good way to kind of quantify that is through the opportunities that the team began to suggest. So 2 of the most successful projects were, the first one was a nighttime setback project in an ambulatory care building. So this was a building where we used to run 5 air handlers at night all the time. And now we rewrote the programming so that it's running only 2 at night, which is great. That is a project that saved about $100,000 in utilities. And with the utility incentive was less than a 1-year payback. We also had a suggestion to implement timers on our autoclaves, and that alone saved 18 million gallons of water a year, which was about 10% of our campus's water usage. So that was huge. And just in general, I'd say that we're a lot better at doing internal best practices sharing and better onboarding than we have in the past. A great anecdotal improvement is that as a team, we've gotten a lot better at not relying on BMS overrides. It used to be a pretty common crutch for responding to hot and cold calls to just increase or decrease the temperature set point. But during the grant, we put into place a temperature set point standard, and then the supervisors worked closely with their team members to reinforce that overrides are a troubleshooting tool, but not a permanent solution. and to work together to diagnose the underlying HVAC issues. And that ended up being a great learning opportunity as well. So this is our team of supervisors. And then to close out, don't take it from me, take it from this anonymous review that I found on Indeed.com towards the end of our training grant. I promise I didn't write it, but I think it speaks to the culture of continuous learning and energy efficiency that we're trying to build here. So thank you so much.
Thank you. That was great. We have 20 minutes for questions, and I do see a few coming through the Q&A here. I neglected to introduce myself at the top of this panel. I'm Jordan Sager. I'm the energy manager at UC Santa Barbara, and so I do want to throw one concept out there. I do see this presented in the Q&A, and I'm curious myself. The cities of Santa Barbara and Sacramento have both introduced prohibitions on new natural gas connections for new construction. I know the city of New York has been debating this since it was introduced by Mayor de Blasio in January. I'm curious to hear from Delia on the situation regarding these types of electrification or fossil fuel prohibitions, rather, in and around some of the universities that are part of your system in Mexico.
Thank you. Right now, I was writing an answer from a question regarding the question you already made.
Mm-hmm.
Our electricity system right now is facing a change in law, which is very important for our country. There is an initiative that is changing the electricity law or energy reform made by the former president. And in case this energy initiative is approved, it could privilege the use of energy coming from oil, and not necessarily renewable energy. So we are facing that problem in Mexico, and our electricity system relies on, we already have different producers, and those producers uses renewable energy, but we also have energy coming from oil and carbon, even carbon here in Mexico. And I really hope that the energy initiative privileges renewable energy, because in case it passes, we are going to have a big problem to achieve our goals.
You mentioned you highlighted a parking building.
Mm-hmm.
Do you provide electric vehicle charging infrastructure in your new buildings of that type? And generally, is there high EV uptake?
Yes. Yes, we do. We have different electricity chargers in different buildings around the country, but mostly in the hospitals and campuses that are concentrated in big cities. But the E2 park is provided with 2 parking lots with electricity chargers.
Okay,
So,
nice.
I'm sorry, we try to have it more.
It's something. Angela, there's a lot of interest in the training center. So someone was surprised to hear that the lab was funded entirely by a $50,000 grant and no other funding. How much of this work, the design, the build out, was done by in-house staff? How much did you contract out? Can you talk a little bit about the process there?
That was the trick to how we kept costs down. Was a lot of it was using in-house labor. So our controls team had some controllers lying around, and they wired everything up themselves. Our electricians, in partnership with our lighting vendor, designed and constructed all of the lights in the room. We just needed some assistance with procuring the lighting fixtures. And then we used our existing service contracts with the BMS vendor and our lighting vendor to try to get these panels online. The biggest cost for the learning lab was just the ductwork, to be honest. That was probably 30K of it. And that was just something we couldn't do in-house. But everything else we pretty much did ourselves, which was how we kept costs down.
Nice. What's the square footage?
It's not that big. I don't know. I'll look it up and throw it in the chat.
Okay. Sounds good. Yeah, I imagine, reaching out to vendors for, donations of, controllers, VAV boxes, whatever it might be. I can't imagine you'd get many no's to that question, especially if you put their sticker on it or something.
Yeah, I think we also had some stuff just lying around too. That fume hood would have cost quite a bit, but it was really fortuitous. I put out a call to our capital planning project managers and asked if anyone was throwing away a fume hood. And actually someone was in the building that we were building the training room. So we just kind of stopped the contractors and asked them to move it up in the building instead of tossing it out. So that was
got it.
Yeah.
So after you train technicians, is this a prerequisite for a merit increase, either salary increase or any type of promotion? And then follow-up question: do you do any training of non-Cornell employees through the teaching lab?
Yeah, I think we do want to use it as a way to be consistent about the way that we promote from within. Like I said, there were kind of broad skills gaps and even within the same levels of technicians. So this kind of helps the management staff understand, like, okay, what do we expect from a mechanic helper? And if this person wants to have a conversation about how to advance with their supervisor, that's great. But what should we tell them that they should get trained on? What are some gaps we want to fill with that specific person? And then we built this training lab kind of with our own staff in mind. So it's just being used internally.
Great. I see a few questions for Scott coming through, and Scott, you did a great job at replying to a few of those real-time questions about electric appliances and expanded net electrical capacity in the residential setting. So maybe I can kind of paraphrase some of these and just generally put the question out. What do you see as the biggest either trends that are coming down the line or needs that we're facing with respect to consumer appliances in a residential setting in order to make this transition to full electric homes as successful as and economical as possible?
Yeah, well, one that I talked about in the Q&A is 120 volt heat pump water heaters are being produced today. You just can't buy them. That'll help alleviate the need for panel upgrades. It's not going to eliminate them because there's other appliances that may need more amperage. So that'll help. It's not going to be a panacea, but I think one of the big things was, once we can get through the supply chain issues that we're having now in society, so HVAC will be more available and hopefully prices will come down. I don't know about that, but I think they certainly will for induction cooking. I think right now it's really hard to get induction. I mean, it was hard before the pandemic and the supply chain issues, but that'll be another one that just brings for residential, it's really going to be about finding lower cost alternatives to gas cooking. On the commercial side, the biggest challenge today is really on central water heating, heating large amounts of water and having it available. That's been worked on extensively and will continue for many, many years, but that's the biggest challenge. I can't say that there's a solution coming anytime soon, though. Not a simple solution that you can just replace a gas boiler with an electric one so easily.
Yeah. So the heat pump style tank type domestic water heaters is the reason for the necessity for 240 volts the backup resistive heating element that most of them have, right? If you drain the tank and you can't keep up with the compressor, obviously the unit would, in most cases, switch over to that resistive heating element to provide additional hot water. Is that what's driving that need for higher voltage?
Yeah, I mean, I think originally I think the short answer is yes. The resistance, the 240, the reason that exists is so that you can have a resistance element in the tank and heat water faster. Depending on the climate zone, it's not necessary. I turned off my resistance element in my water heater 9 months ago, and I've not taken a cold shower. I do think, so the 120 is a viable solution in moderate climate zones. Where it gets really cold, it's less well known, but the 120 volt versions come with even a larger heat pump than the one that I have on my 240 volt. So they'll be able to heat water faster. I think the other issue is we don't need hot water when we step out of the shower. We only need hot water when we step into the shower and during that process. So it's not about heating. They're not on demand, and the gas tank ones aren't on demand either. So we just need to schedule and plan how and when the water heater's operating, and you can have plenty of hot water supply. The other thing is to just to ensure that and to maintain your tank on heat pump mode is to have a larger tank. So the standard gas is 40 gallons. The standard heat pump is 50. Go to 65 or 80, and you'll just get that much more capacity.
Yeah, and you mentioned scheduling, and I think you wrote this in one of your answers. This is something that we are obviously expanding our capabilities around demand response signals directly from the utility, not only for hot water heaters, but all kinds of electrical appliances. Is Smud doing anything in this regard? Are there automated demand response programs that you're running or envisioning introducing in the near future?
We do have a program now that controls the water heating. There's not a huge uptake. It's kind of still, I wouldn't say exactly in pilot, but we're using it. But from what I've seen, with knowing the solar window and knowing the rate structure of my utility, I schedule my water heater to run every day from 9 to 3, but usually it only runs from like 9 to 10 or 11. But that's the lowest carbon footprint of my electricity, but it's also the cheapest electricity. So usually most days it only runs in that window, and it doesn't operate the rest of the day because it's storage. It can store enough water heat for 4 showers that night, and then it'll heat it back up the next morning.
Awesome, thank you. Okay, I'm going to go back to the Q&A for a second, see what we got. Angela, can you elaborate on autoclave timers? Is this something that you mentioned in your presentation, timers for autoclaves?
Yes, and there's some, I gotta find it. There's a good link I'll try to leave in the chat as well about it. But basically the autoclave timer project was implemented in our 18-story medical research building, and every floor had its own autoclave, which is used to sterilize equipment. So our autoclaves in that building use steam in order to sterilize, but then also in the jacket of the piece of equipment, and potable water is mixed in with the steam condensate to temper the condensate as it goes down to the drain. So that potable water was adding up across all the autoclaves, like a gallon a minute or something like that per autoclave. And it was a lot. You could hear the solenoid just kind of going all day, all night. But the truth is the researchers weren't running the autoclaves all the time. They only needed it when they were working. So we kind of polled and asked what a typical schedule was. And then we had a service vendor already for the autoclaves. And for like $1,500 on their next site visit, they installed timers that would kind of put them into like a standby mode. overnight. And that meant that we didn't have to temper the condensate, which meant that we didn't need potable water. And it was like a crazy amount of water that was saved. And it was very low cost too, so instant payback.
So for $50, you could get this device installed and set up. What do you think was roughly the payback on that move?
I was just trying to remember what the cost of our water is. I want to say it's like 1.3 cents or something like that per gallon. I think it was around $200,000 a year in water savings, something crazy like that. Yeah.
Yeah. Okay. Thanks. Actually have another one for you. Do you use the same BMS and lighting system, control systems across your facilities, or do the techs need to be versed in several vendor systems? I heard you mention 2 HVAC BMS systems and at least 1 lighting control system, but can you talk a little bit about the diversity of control systems that you're working with?
Sure. We actually have 3 vendors, but 2 of them we use the most. So that's what we put in our learning lab. And so 3 building management system vendors, and then a couple of different lighting systems, but the most complex was the Lutron Quantum. So that's what we did in the learning lab. The truth is, yeah, this was a major part of the training grant, was that our mechanics often have to cover each other's zones in different buildings. So a mechanic might be very familiar with one building management system, and then they're kind of lost when it comes to the others. And so you just kind of hope like nothing goes really wrong when you're covering that building on an off shift. And so a lot of the controls trainings that we ended up spending the grant money on was just to train people on the other building management systems that they didn't spend as much time with. So yeah, that's kind of an ongoing challenge. And then also a lot of our building management systems are going from software hosted on campus to web-based, and that is a big jump in technology as well. So we're having to train on that too.
Yeah, but the networking, I guess, IT proficiency component of all of this is very real. I think as our last panel demonstrated. Delia, I'm curious, at your university, do you have any type of standardization for these types of systems, HVAC controls, lighting controls? How does that work? Do you get something different with each new building that you put in, or are you standard across the board, or somewhere in between?
We have control system from Johnson's Control. The vendor is Johnson Control. We do have a Metasys system, and we try to monitor everything that is happening in the HVAC control. And we just built another building that is called Wellness Center, and we run different set points and different arrangements of the Metasys program, and we arranged a new set point so we could keep the temperature and the comfort in the building. So we use Metasys from Johnson's Control, and we are trying to apply a monitoring system, and we are trying different pilots, different programs, and let's see what's going to happen, because we are about to start these new systems.
Okay, great. Well, we are about at time, and we've been through our questions. Ali, I'll connect with you on one that came through just now. But any housekeeping we need to do before we cut folks loose for the lunch break?